group and I are going to present about our centripetal force experimentation. Our objective is to determine the gravitational acceleration by doing centripetal force experimentation and to prove the formulation of centripetal force.
So what is centripetal force? Centripetal force is a force that causes an object to deviate from its straight trajectory into a circular one. This force aligns with Newton's first law of motion, which states that an object in motion will remain in motion unless an external force is applied. In this case, the external force in question is, the centripetal force, which pulls the object towards an axis so that it can move in a circular path. As per Newton's second law, this force does equal to the product of the object's mass multiplied by its acceleration. For this experiment, the apparatus that we used includes a rubber stopper, a plastic tube, and a stopwatch. So what we did was we tied a string to the rubber stopper to attach it to the plastic tube so that we could spin it around. So to conduct this experiment, we have to mark the string at certain lengths, and this is going to be our radius for the circular motion. Then, we're going to spin the rubber stopper above our heads, aiming for a constant radius. To check that the radius is constant, we have to make sure that the length of the string does not fluctuate, and we can do this by using the mark that we put on the string as an indicator. Once the motion is constant, have a friend start a stopwatch as we count 10 revolutions. Record the time taken as data. The data that we collected, the time taken for 10 revolutions to happen differs for each radius. This means that each radius resulted in a different period for, one revolution to happen, which means that we have to find the period for each individual radius. To find a period, all we have to do is divide the time taken by the number of revolutions. So for example, we have 4 seconds for 10 revolutions, and that means we have to divide 4 by 10. That we're going to process our data into a graph like the one shown here. So our graph compares period squared and radius, which means that the gradient of our graph is going to be period squared per radius, whereas the formula given to us by our teacher goes as follows: F equals to 4 pi squared multiplied by the mass of the object in revolution multiplied by radius divided by period squared. This suggests that we have to inverse the value of our gradient in order to incorporate it into our formula. And our new formula is going to look like this. Calculations show that the gravity on Earth is about 8.7 meters per second squared. However, this is not true as the gravity on Earth is actually 9.8 meters per second squared. Now this leads us to believe that our experiment is flawed in some way and has some significant error percentage. So we've calculated our error percentage and it turns out we have an 11% error, which means that our experiment is not accurate. This error can be attributed mainly to human error as the only apparatus that we really used to measure was a ruler and stopwatch. One of the human errors that could have occurred was instability when spinning the rubber thing above our heads, which would cause the radius to fluctuate and the period to be flawed. Unfortunately, our experiment is unable to prove that Earth's gravity is at 9.81 meters per second squared. However, from this experiment, we can still learn a number of things, including the fact that centripetal force does indeed exist, as it causes our rubber stoppers to move in a circular path. That's it for our presentation or our experiment report, and thank you. Have a nice day. Please give us a good score.